So hi everybody, I'm happy you're watching this video from our private pilot license theory training course. So now we are going to talk about undercarriage, landing gears, or maybe it would be better to say landing gear. I'm not sure about the spelling of this term, so if you know, please let me know about it, okay? So the previous video from this video course was about the construction of the control surfaces of the airplane, of light airplanes, and the next one will be about the construction of engine and propeller, in other words the power plant of the light airplanes. So now we are going to talk briefly about the construction of landing gear, about fixed and retractable landing gears, and also we talk about tires and braking system. Okay, so I think everybody knows the reason why we have the landing gears on the aircraft. So first of all, to provide ability of the maneuvering the aircraft on the ground. So we have to change position of the aircraft from one point to another, from apron to the runway, to roll out the aircraft during takeoff or landing. And the second meaning is to support aircraft on appropriate height above the ground to keep the fuselage, engines and propellers clear of the surface. And also the main idea of using landing gears is to absorb kinetic energy on landing. On touchdown moment of the landing, aircraft has vertical speed and therefore it has kinetic energy. So, and this kinetic energy have to be absorbed in order to prevent the fuselage and airframe of the airplane from damage. And also additionally, the landing gears allow us to provide the acceleration landing rollout. In other words, just allows us to make braking during the landing. So basically we have two kind of landing gear layouts. First one is a tail wheel. The second one is a tricycle with nose wheel in the front of the aircraft. So let's say a couple of words about the tail wheel layout. So I think you would find those kind of aircrafts quite rarely, because this layout, this construction of landing gears is normal only for old aircrafts. So on most contemporary aircrafts, modern aircrafts, you won't find this construction. So because this construction is quite almost easy and cheap, and this small tail landing gear creates less parachute drag, and also because of we don't have any ways to directly control the direction of the aircraft while taxiing, while moving. This aircraft with this landing gear has bad steering ability. So actually you could steer the aircraft, you could change direction of the aircraft by applying differential braking on the main gears, and also in case of the sufficient airspeed, you could use a rudder to control the direction of the airplane. So you can control the direction of the airplane aerodynamically, and that's why these kind of airplanes are affected by the cross or tailwind. Tailwind, in the case if you use rudder to direct or to steer the airplane on taxi, could lower the airspeed and eliminate the aerodynamic forces. So it brings the problems with control aerodynamically airplane, and also reduce aerodynamic forces, and also the crosswind could just, for example, the gust of the crosswind could just rapidly change the direction of the airplane, and you could just it could just bring to the accident. You could drive off the runway, for example. And also because of the lack of the support in the front part of the airplane, there is a risk of nose over flipping the airplane on hard braking, for example on landing. And also there is one more problem with the vision from the cockpit. Actually, in this kind of airplanes, you won't see anything from the pilot seat. You have to perform some called S-turns to keep the taxiway in front of the aircraft clear, or you have to use the help of the ATC or help of other observers on the airport to keep the position, the space in front of the aircraft clear. So everything is better with nose wheel layout. So in this case, first of all, aircraft is directionally stable on landing and taxi, because in most cases the landing gear, the front wheel, is equipped with a steering mechanism, so you can literally steer the aircraft by pushing pedals. And also because this front wheel is placed far from the center of gravity of the airplane, these airplane with this construction of landing gears are stable, so they are sustainable of nose over flipping on hard braking. You can apply braking as much hard as you want. And also because almost horizontal position of the aircraft while taxi, pilot has the good view from the cabin, and there is no problem any problem to keep your way clear. So now let's move to the landing gears. So about the mounting of landing gear on high wing airplanes 172, you would find the fuselage mounted gears. Here we can see the steel tube just mounted to the fuselage. And on low wing airplanes we would find the wing mounted airplanes. There is no big difference with this construction. I just want to mention that there could be some construction difference in between the high wing and low wing airplanes. Need to say that main landing gear takes about 90% of load on taxi, and actually 100% of loads on touchdown. So the center of gravity of the airplane is placed very close to the position of landing gears, and the main landing gears are constructed in the way to keep most of the load on them. So the front wheel, the front landing gear is not intended to keep too much load. So if you first touch down on landing with the front landing gear, you would just literally it would just be collapsed, and it could cause the accident. So always need to perform touchdown with main landing gears first. And also only main landing gears are equipped by a braking system. So about nose landing gear, this is the standard nose landing gear for Cessna, and usually it's steered. There is a mechanism to change the position of the direction of this landing gear. It can be on some aircraft self-centered, when you again just steer or change direction of movement of the airplane by applying differential braking. So let's talk about the construction of it. Here we can see the auto pneumatic strut. This strut is constructed of the cylinder and piston, which could move up and down. So the air in this cylinder creates like something fusion, and absorbs kinetic energy when piston moves up and down. So here there is some element of the construction of this strut. It's called torque link. This torque link is connecting upper part of the cylinder of the strut and the lower part of the piston of the strut together without any without creating resistance in the movement of the piston up and down. So this torque link just links together upper and lower part of the strut and allows to keep direction of the wheel together with the cylinder. So here we can see the shimmy damper. Shimmy damper is the element which prevents the shimmy effect, which is dangerous, can cause the destruction of the landing gear. So shimmy effect can be caused by wearing of the tires or wearing of the bearings in the hub of the wheel. So how shimmy damper works? So the shimmy damper is kind of cut small oscillations of the wheel when the wheel moves very fast from side to side. So shimmy damper absorbs these small movements without any restriction in the turning this wheel from side to side. So it does allow you to turn the wheel from side to side, but it dumps small oscillations. So to absorb kinetic energy, we use shock absorbers. So we actually already talked about spring steel leg on Cessna 172, for example. There is a spring steel leg used on the main landing gears. It's just a steel tube which bends under the load and without any deformation. And also we saw all pneumatic strut on the front wheel, on the front landing gear of the aircraft, the same Cessna. And also you could find the rubber cord shock absorber. It's like, I think you could find this on the old airplanes. It's just a rubber cord, literally folded together, which stretches under the loads. And also you could find the rubber pad absorber. Never seen them, but I think the way of action, it's clear. So there are some discs made of rubber, and they are compressed under the loads. It's clear, I think. So about the fixed and retractable landing gear, let's first talk about fixed landing gear. So this construction is cheap and low in cost and maintenance because there is no additional elements in construction, just springs, struts and wheels, nothing else. That's why this construction is lightweight. So but because of this wheels or landing gears stuck out of the fuselage, they bring us a high parachute drag. So that's why these fixed landing gears are used only for relevantly low air speeds. For aeroplanes with speed, let's say 150 knots, I think not more. And sometimes you could find the fairings to make parachute drag less, but anyway, this construction has a high drag. So retractable landing gear are efficient for high-speed airplanes because of actually zero drag in retracted position, but because in this case we have a lot of components to manage the position of the gears, of course the system brings additional weight, so airplanes are more heavy in this case and more expensive and more complicated in maintenance because of additional systems. And also it brings additional how to say, operational load on the pilots, because there are operational limits in airspeeds. Gear can be retracted and extracted only on limited airspeed. And also there is one more plus, I think, on retractable landing gears, that airplanes better for emergency landing without gears. With retracted gears, I mean on soft surfaces, or in case of ditching into the water. So let's say a couple of words about retraction systems. So this system actually is just a set of levers, mechanical levers, which could allow us to fix or lock gear in up and in down position mechanically. So they are self-locked, and to move this mechanism from up and down position and back, actually pneumatic or hydraulic or electric actuators are used. So pilot should control the position of this landing gears from the cockpit, from the cabin. So to control this landing gears, we have primary circuit and emergency circuit. So the primary system is just normal system which is operated normally, and you could find some kind of lever or knob on the dashboard to change the position of landing gear, to move them up or down. And also for emergency situations, you could find the emergency control for locking down the landing gears. It could be a kind of manual unlock and free fall landing gears, when landing gear go down under the gravity forces. And on some airplanes you could find the secondary hydraulic pump, and on some bigger planes there could be the additional pressure system, secondary pressure system with the secondary pumps, secondary power lines, hydraulic power lines. So which created to fully duplicate the functionality of landing gears. So to control the position of landing gears in up and down, we have control indicators on the dashboard. So on airplanes like Cessna or Piper, on common training airplanes, you would find these three green lamps, which usually glow in when gears are locked in down position. On some airplanes you could see lamps which indicates you that landing gears are in transit position. And also to be sure that those indicators are working on some airplanes, I think on most airplanes, you would find a way to control that the system of the circuit is working. If you, for example, on Cessna, on Piper 28, if you push those indicators, you would see that lamps glow. That means that indicator system is working properly. Okay, so let's highlight the usage of retractable landing gear. So as we said, that retractable landing gear brings additional load to the pilot, so additional responsibility. So need to always follow to checklist on complicated airplanes with retractable gears to be sure that gears are locked down on landing. You always have to control airplane speed to keep airplane in the limits of the airspeed before operating gears up and down, and always need to know and remember emergency checklist for different situations. and there could be some additional how to say actions while operating landing gears in freezing situation to prevent the landing gears of freezing in case of if you use aircraft, if you fly in near to zero temperature. So you need to make sure that landing gears are cleaned of the slushing snow, for example, by retracting, extracting landing gears twice. So let's turn now to the construction of wheels and tires. It's the same as for cars. There could be tube or tubeless tire on the wheel. The construction is very similar to the tire of the wheel of the car. We can see here the hub is usually made of the magnesium or aluminum alloys to make it lighter. There is the inflation valve, which allows us to inflate the tire and check the pressure inside of it. And there are bearings which allows us to keep the hub connected to the axis. And I think we talked already about a fork which holds this wheel connected to the strut. So everything is easy, simple. So about tube tires, I think I could say that I can say that inside of the tire there is a special rubber tube which keeps the pressure, keep the pressurized air inside, and this is inflation valve is connected to the tire. So that's why it's this construction is a bit heavy, and let's say it's subject to damage in case of tube creep. Why? Because in case of the creep of the tire on the hub, for example, in case if tire is not inflated properly with low pressure, and on intensive braking the tire could creep on the hub, and this will bring, in this case if you have tube tire, it will bring to rapid loss of pressure. This inflation valve will be torn off, and it could bring to the accident. And but for tubeless tires everything is better. It's lighter because of lack of the inner part of the tire of the tube, and also the because the inflation valve is placed on the hub of the wheel separately of the tire, so creeping of the tire will not cause any problem at all. And the construction of this tire, tubeless tire, is quite better in this case, and so tubeless tire are not subject to rapid loss of the pressure. So let's now talk briefly about the braking system. So braking system is again quite simple on light aircrafts. On most aircrafts you would find the hydraulic braking system. On some a little bit more complicated, you would find the pneumatic braking system. But again, on most aircrafts you would find hydraulic braking system, which looks exactly like the system in the cars. So for example, in this picture we could see how this system works. So for example, if we press this foot pedal, this movement creates pressure in the main cylinder, in the master cylinder. This pressure goes to the slave cylinder, and pressure makes this brake pads, they push the brake disc, and so we have here the braking action. This brake disc is connected to the wheel, is mounted on the wheel. So, and pushing the pedal causes the braking action. As we see on this picture, this is the strut, I think the main strut surely of the aircraft, and here we can see the brake disc, and this is the slave cylinder, and this is the power line. So the system is quite simple. Just I would like to mention that there are usually 2 sets of pedals in the cockpit, in the cabin, for each pilot separately, and so we have here, we can see here that the braking system is differential. So for each side of the aircraft, for each main gear, we use the separate pedals to apply braking action. Left pedal with brake on the left side, and right pedal, of course, will create braking action on the right side. So everything is simple. They are combined to each other. They create the same action. I mean, on both sides of this pedal sets, and but just with one exception, that left side has kind of priority on braking. So you can additionally brake on the left side because the left side is intended for pilot in command. I think that's it. It's just brief overview of the undercarriage of light aircrafts. This overview will be enough to pass the theory exam on level of private pilot license. So in case if you have question, please ask, comment. I would be happy to answer. And thank you again very much for watching this video. Next will be about the construction of engines and engine and propellers. So thank you very much. See you in the next video. Bye.